Hello, I'm Bob Swikart, A-Plant Superintendent at the Union Carbide Uravan Mill. With me today is Howard Stevens, the Safety Engineer for the mill.
We'd like to welcome you to Union Carbide, and the purpose of this videotape is to introduce you to the Uravan plant production process as well as the safety aspect of our plant. We would like to mention that safety is governed by MSHA, the Mine Enforcement and Safety Administration. We do comply with all the MSHA standards as much as possible. We have a very good safety program, but safety is 90% the individual, and as your responsibility, we would like you to work as safely as you possibly can while you're working in Uravan. Bob, you want to explain a little bit about the process of our plant here?
Okay, Howard. We've had an operation here at Uravan since 1915. Of course, it's undergone many changes, but now the process is to extract vanadium and uranium from the ore that we receive. We do that in two areas. The upper plant is called the B plant area, and the lower plant is called A plant. In B plant, we receive the ore. It's crushed, sampled, and ground to a fine consistency. Then we use a hot sulfuric acid leach to put it into solution. When the vanadium and uranium is in solution, it comes down the hill by gravity to what we call A plant. There we have two processes. The first process is ion exchange, which extracts the uranium from the solution. The second process is solvent extraction, which extracts the vanadium. The uranium is then further processed, and it leaves here as a dry yellowish powder called yellow cake. That's our final product for uranium. The vanadium leaves here as a concentrated vanadium solution. It goes on to our plant at Rifle, Colorado. Uranium is used as fuel elements for nuclear reactors. The vanadium, after it leaves here, is changed into various oxide forms, and it is used as an alloying agent for steel and titanium. Well, should we go see the mill, Howard?
Let's go see the mill, Bob.
All the ore at the Uravan mill is received by trucks, comes up this road to B plant. The ore comes from various mines located in western Colorado and Utah. Howard, did you want to comment on the hazards of the approach road?
Okay, Bob. Vehicles are probably the leading cause of accidental deaths in the United States today. Here we have a very steep grade. The road is coming up to B plant where they dump the ore. And along with the steep grade, we have a very severe drop-off. And this drop-off runs a full length of this particular road right here, Bob. You also have a possibility of having ice and snow on this road, along with rocks coming off the bank on the other side.
I might mention that most of the mill traffic goes up a different road. We don't use the same road that the ore trucks use. Our first operation starts with the truck pulling onto the scale. We have electric eyes that indicate when the truck is located on the platform of the scale. The driver gets out and calls down to the ore receiver to tell him what load of ore he has and where it came from. The ore receiver weighs the truck and by phone tells the driver which bin to dump the ore into. The ore receiver initiates the scale ticket, which identifies that particular load of ore. The driver then pulls the truck down to the particular receiving bin. We have 8 bins. He backs up and dumps the load of ore into the designated bin. The ore has to fall through a 14-inch grizzly. And this is probably another hazard that you want to talk about, Howard.
The grizzly is the leading cause of accidents in our plant right now, with 3 out of 5 accidents happening in the ore receiving area this year in 1978. Probably the main cause of accidents is handling the ore and slipping and falling. Slipping and falling, you have rocks on the grizzly. When the truck dumps his load on the grizzly itself, it piles up and you have rocks falling off the top of the grizzly, off the top of the ore pile. The rock will fall off and it could strike the employee's shin or go on his instep of his foot. For this reason, we have and require metatarsal guards for every employee that is working on the grizzly right now. We are now required by MSHA standards to wear a safety belt and safety line on the grizzly. Another hazard is with the truck itself, and the bed is in the up position. The truck is unstable, and there has been times where the cylinder has broken, causing the truck to tip over. Luckily, we have never had an injury in this area, but we do require our employees to stand well clear of the truck while it is in the up position. The other hazards we have in this area, Bob, are noise, which noise indirectly is a hazard, and it indirectly could lead to accidents. Our noise dBA in this area runs from about 85 to over 110 decibels at times. During the winter times, there are hazards with ice on the pad. We have and are required to salt the area, so we try to take care of this type of hazards.
All the ore from the receiving bin goes up this conveyor and drops onto a 2-inch screen ahead of the primary crusher. After the ore goes through the primary crusher, it goes through the sampling operation involving these sample buckets shown here. The principle of sampling is that we want to take a successively smaller portion of the original stream of ore, crushed to successively smaller particle size. The result is that from a 30-ton load of ore that included 14-inch rock, we end up with about a 30-pound sample of minus 1/8 inch material that truly represents the composition of the original truckload. The ore goes through a Rolls crusher and then into a Wiesen splitter and drops down, the sample rather, drops down into the canvas bags shown here. That 30-pound sample is further reduced by the sample bucker into about a 1-pound sample. The 1-pound sample is sent down to our laboratory here at Uravan, where the sample bucker reduces it to about a 100-gram sample, which is sent to Grand Junction for analysis of uranium and vanadium.
Bob, in the sample plant there are many pieces of moving equipment which we are required by MSHA standards to guard this equipment, and we do guard it to MSHA specifications. Housekeeping is also a hazard in this area. We like to have as good a housekeeping as possible because you have a lot of rocks that fall off the belts, and of course poor housekeeping leads to falls, and falls is the second leading causes of accidental death in the United States today. Other hazards are noise hazard, which this is one of the areas in our plant which we do require some type of hearing protection when you're working in this area. Along all of our belts we have an emergency stop cord. The stop cord runs along the side of the belt It acts as an emergency procedure in case you have to stop the belt.
This is a picture of the conveyor belt that takes the coarse ore up to the coarse ore bins. All the ore is 2 inches or smaller at this point. In this picture, the sample plant operator is selecting the coarse ore bin to receive the ore from the sample plant.
Bob, I might mention that the sample plant operator must be notified and the traverse conveyor must be locked out anytime cleanup or other work is being done in the coarse ore bins.
Yeah, that's right, Howard. Up at the top of the coarse ore bins, the ore can be dropped into any one of 7 bins, and there's a switching mechanism that enables you to select the bin you want to go to. This is a picture of the bottom of the bins. Each bin holds about 300 tons of ore, feeds out the bottom of the bin onto one of 2 conveyor belts. In this picture you can see the ore dropping onto the feeder and onto the conveyor belt. The ore is conveyed on into one of 2 airfall mills. These are dry grinding mills where the ore tumbling over itself has a grinding action and eventually breaks the rock down into a very fine consistency.
As in the sample plant, Bob, one of the hazards in this area is conveyor belts. We are required by law to guard both tail and head pulleys and have a stop cord along the entire length of the conveyor belts, which we do. One thing about the airfall mill is be sure to obey all signs. Find out where the safety showers, eye wash fountains are in each area.
The airfall mills dry the ore as well as grind it on down to a fine consistency. There's an open flame that blows through that mill, and eventually that flame and the sweep of air moves the fine particles outside of that rotating cylinder.
We have a lot of equipment in this area, a lot of moving machinery. All machinery are guarded according to MSHA standards. But still, each individual has to take an individual responsibility.
The airfall mill area is another area where hearing protection is required, isn't it, Howard?
Yes, it is, Bob. DBAs in this area are from 90 to 100.
This is a view of the control panel for the airfall mill, showing the various means of selecting the coarse ore bin, the buttons to start the mill, the gauges that indicate the conditions going on in the grinding circuit and the mill circuit.
Anytime, Bob, that there's work to be done in this area, each individual must be sure to follow our lockout procedure, which is found in our safety rules book.
It's not all hard work, you can see there. This is a picture of the conveyor belt that takes the ground ore, the fine ore, out of the airfall room up to the fine ore bins. These are the same configuration as the coarse ore bins. There's 7 bins, and at this time the ore is ground down to a real fine face powder like consistency. This is a picture of the bottom of a fine ore bin. Like the coarse ore bins, the fine ore bins feed out onto one of 2 conveyor belts.
At times in that area, Bob, we have a dust problem. If there ever is a dust problem in this area, be sure to wear a dust respirator.
The ore from the fine ore bins goes in 2 different directions. Most of the ore goes through an acid kill step. Part of the ore goes on through a slimes leach process, and I'll talk more about that later. In the acid kill process, some of the excess acid from the leaching solution is brought back and used to neutralize the carbonate in the ore. That's where the name acid kill comes from. For now, we'll just follow the process through the acid kill step and on into the total ore leach. Howard, did you want to say something about the safety in the leach?
Okay, Bob. This is the first area that acid is introduced into the system. That's in the acid kill. Throughout this area and throughout the leach, we have safety showers located in various spots to cover in case you happen to get some acid on you. If you refer to your first aid, anytime you get sulfuric acid, wash it off for 15 minutes or longer. The other point, Bob, I'd like to bring out here is that the liquor itself is 90 degrees centigrade, so it's very, very hot. Okay, again, be sure to obey all signs. In this area you have a danger of high CO2 gas. Carbon dioxide gas is not a poisonous gas, but it does replace the oxygen in the air. And in the main AK sump area, a CO2 test must be made before you enter into this area.
There are 4 inside acid kill tanks. From the inside acid kill tanks, it's pumped to the number 3 acid kill tank, which is on the outside of the building, shown here. Number 3 acid kill tank overflows into number 10 thickener, which is the introduction to the total ore leach step. The underflow from this thickener is pumped to the number 1 total ore digester. This is a picture of the cyclones over number 1 total ore digester. The cyclones are used to make a more dense feed into the ore leach step itself. We have a total of 15 total ore digesters, 8 of them on the outside and 7 of the tanks are on the inside of the building. In these tanks, the ore is heated to a high temperature, the ore slurry, to a temperature of about 85 degrees centigrade by steam. All the sulfuric acid is introduced into the first tank. Sodium chlorate is introduced into the second tank, and these chemicals and the high temperature act to leach the uranium and the vanadium away from the solid ore pulp. This is the inside of the leach building. Have 7 total ore leach tanks on the inside of the building. This is the inside of the leach and CCD control room. Here an operator is measuring the free acid present in the leach solution. Howard, do you want to comment about the safety aspects inside the leach building?
You have some cause sometimes for working in elevated areas. If you are outside the handrails, a safety belt and lifeline must be worn. In this area you also have our Scott air packs, which are located inside the control room in case somebody would happen to be overcome with bad air or a chemical. You have to be trained in Scott air pack in order to be able to use it. Scott air packs will give you up to 30 minutes of air supply if you have to use them. And again, it's important to be trained in the use of the Scott air pack before attempting to put it on. Other aspects of this area as far as safety goes, you are involved with hot liquor and acid. Be sure to obey all signs, follow the safe job procedures, use of proper personal protective equipment when working in this area.
The leach pulp from the last inside digester is pumped to the first of 8 thickeners in series. This is our wash circuit where the tailings are washed free of any uranium or vanadium that's in solution. This is called the CCD circuit. This stands for counter current decantation. The leached pulp is introduced to the first tank and is washed in a series of 8 tanks or thickeners on up to the last tank. From the last tank it's pumped out to a tailings pump house, and from there it is pumped up onto our tailings pond. Here's a view of the 8 CCD thickeners from the upper side. The purpose of the CCD is to introduce a wash solution at the upper tank or thickener, and it progresses on down through the thickeners, and the leached pulp progresses countercurrent to that wash solution up the thickeners. This is a view of the tailings pump house. We have pumps that will actually pump the tailings on to the upper part of the tailings pile. There it shows the tailings going on to the tailings pile. This is number 3 tailings pile, I believe. We have 2 active tailings piles that we use.
In the tailings pile area, Bob, it's important to observe all vehicle safety. You're traveling on elevated roadways, and be sure to observe the speed limit signs and dangerous driving conditions.
That was a view of number 9 thickener. Number 9 thickener, the uranium and vanadium in solution, travels down the hill through these pipelines by gravity. This pipe trestle also carries steam, domestic water, and processed water up the hill. The processed solution comes down the hill to A plant. And this is the start of the operation where we separate the uranium and the vanadium from the solutions. As I said previously, certain of the ores we receive are more refractory than others. That is, they require a more severe acid leach to put the vanadium into solution. These ores are put through the slimes leach circuit before they continue on to the regular leach circuit. In the slimes leach circuit, we use extra acid, temperature, and residence time to help put the vanadium into solution.
Okay, here's a picture of a safety shower and eye wash that we have in the slimes leach. Part of the operator's job in this area is to check the safety shower to see if it is full and working each shift. So other safety features in this area, you have a hot liquor, you have steam and acid and other dangerous chemicals in this area. Be sure to obey all signs, wear your protective equipment, and know the Uravan piping color code.
The ore from the slimes leach joins with the rest of the ore in number 1 total ore digester and follows through the rest of the total ore leach process. Since sulfuric acid is one of the main reagents for our process, we manufacture most of the sulfuric acid we use. We purchase some acid, which is delivered by tank truck. This is a picture of the acid plant where we make sulfuric acid. It is the only operating sulfuric acid plant in Colorado. It uses the contact process to make acid. In this process, the acid is made by 3 steps. 1, to burn the molten sulfur to form SO2 gas. 2, to convert the SO2 gas to SO3 gas by passing it over a catalyst. And 3, to absorb the SO3 gas in a circulating acid to make a higher strength or more concentrated acid. In this picture, the molten sulfur is stored in the silver tank in the foreground. The sulfur is burned in a horizontal chamber just to the left of that storage tank. In the background of the picture are the catalyst tower and the drying and the absorbing towers that complete the process for making sulfuric acid. This is the acid plant control room. Once the acid is made, it's stored into one of these horizontal tanks or in a large vertical tank we have south of the acid plant.
Here's a picture of a wetsuit and goggle area sign. In the acid plant, splash goggles and face shields must be worn anytime you go out into these posted areas. You also must wear wetsuits anytime it's necessary to go into the acid plant where there's a danger of being splashed with sulfuric acid. One thing that you should know in this area is first aid procedures if you happen to get sulfuric acid or other chemicals on your skin. The first aid procedure mainly is to wash the affected area for 15 minutes or longer with water. Again, it's important to check your safety shower and eye wash fountains each shift.
Returning to the process, the solution containing the uranium and vanadium comes down the hill along this pipeline, along this trestle. The trestle not only brings the solution down the hill, it also is used to take the process water and a certain amount of the steam up the hill. The uranium-vanadium solution comes down the hill and is stored in 3 large A-liquor storage tanks at the bottom of the hill. The solution from these 3 tanks goes into the ion exchange process. This is a process where we take the uranium away from the solution. It's done by the use of ion exchange resin beads. that have the ability to absorb the uranium out of the solution. This is a view of the ion exchange columns. We have 6 columns. These are the columns that contain the resin beads that extract the uranium. Also, in the ion exchange process, we use acidified water to wash the columns. This is there's a considerable amount of acid use in a plant, and it's also one of our safety hazards that we have down the hill. This is the ion exchange control room.
In each operator station we have safety boxes located. In the boxes we have different information for operating procedures, safe job procedures. We also have safety suggestion forms for you to fill out if you have a safety suggestion that you feel like we can make a change in operation or in our different locations to make the job or hazard safer.
In the ion exchange process, after the uranium is loaded onto the resin beads inside the column, we introduce strong sodium chloride brine into that column. That acts to take the uranium back away from the beads. So the net result of the ion exchange process is that we've purified and concentrated the uranium into a more concentrated brine solution. The brine comes from Paradox Valley. It's a naturally occurring brine that's pumped to us. The salt brine from the ion exchange process that contains the uranium is pumped up to the first of 3 uranium precipitation tanks. We use either hydrogen peroxide, caustic, or ammonia as the reagent to cause the uranium to precipitate from solution as a solid mud. This mud is gathered in the bottom of our yellow cake thickener. It's pumped from the bottom of the yellow cake thickener through a plate and frame filter press. Inside the filter press we separate the mud from the filtrate or the solution that held the mud. Plate and frame filter presses can be opened, and that filtered mud is dropped into a hopper buggy. You can see we provide white coveralls at this point.
Bob, I might mention that when working with or around yellow cake, personal hygiene is very important. Be sure to wash your hands, your boots, any yellow cake off of your body whenever you are removed from this area.
That's right, Howard. The main hazards with uranium at this point is if it's ingested into the body or if it's inhaled into the lungs in the dry form. The yellow cake from the press is put into a repulper tank and pumped up into the top hearth of our yellow cake dryer. In this dryer, the yellow cake is heated to about 700 degrees centigrade, and it leaves here as a dry oxide form. The dry oxide is dropped into a drum, black 55-gallon drum, which is our product storage and product handling drum. The drums are weighed on 2 scales, the initial weight on the first scale and a check weight on the second scale.
In every area, Bob, we have fire extinguishers located throughout the plant. It's important that you learn how to use a fire extinguisher before you are required to work in most of our areas. And also, when working in our yellow cake barreling area, respirators are required by law. The NRC, or the Nuclear Regulatory Commission, requires us to wear a full half-mask respirator when working in this area.
This is a view of the yellow cake storage area. Each drum is labeled with a lot and drum number. Here the yellow cake drums are being shipped out by truck.
The safety rule that we have in our plant area is chalking all vehicles, as this guy is doing in this picture.
The solution that contained the uranium and the vanadium, after it's gone through the ion exchange column, the uranium has been taken out. However, the vanadium is still in solution. This solution goes on through ion exchange and is pumped out to